Meet Dr. Zuzana Sediva, a biochemist that had a passion for making her own homemade pistachio ice cream that was the key to figuring out a process for producing a biodegradable foamed plastic solution. There was a time where I used to pick them in Sicily and bring them home to make ice cream, she recalls. Back then, she had no idea that this passion would later provide the inspiration for her dissertation and ultimately for her business idea, which will help to reduce foamed plastic waste worldwide. Zuzana Sediva grew up in the Czech Republic. She went to Switzerland in order to study biochemistry. Her interest in foam materials developed quite naturally, as it was a progression from her homemade pistachio ice cream making process. Ice cream is essentially edible foam. Generally speaking, foam is nothing more than a low-density material whose cells or pores are filled with air or gas. Bread and even timber could even be put in the same category. Sediva's weakness for pistachio gelato led her to scientific interest, which in turn led to her business idea. In her dissertation, Sediva was able to demonstrate that her propellant based on gas and water is an effective means of manufacturing foam material. Her experiments once again involved ice cream, this time vanilla flavor. As a PhD student, Zuzana studied the high-pressure, low-temperature process of design and optimization while applying gas hydrates. From March of 2019 until January of 2020, as a postdoctoral researcher, she worked on the melting extrusion of highly viscous carbohydrate/protein systems. This project focused on the development of the entrepreneurial case based on previous research with gas hydrates as a novel foaming agent. At the time of this recording, Dr. Sediva is a pioneer fellow at ETH Zurich, where she is currently helping the foamed plastic industry step away from petroleum-based materials with a low-temperature foaming technology based on gas hydrates. So in short, she's been at this for quite a while now. Her current project focuses on developing a method by which green waste can be processed into biodegradable foam plastics, which can be used in the auto industry, construction industry, and also to manufacture shoe soles, toys, yoga mats, packaging, and even mattresses. In other words, any product that requires the elastic cushioning property provided by foam materials. Now, this is a huge conservation win because at the moment, there are many solutions for bioplastics that are being worked on. However, very few are sustainable alternatives to foamed plastic, mainly because the chemical manufacturing process requires raw materials with very specific properties. Traditionally, conventional plastic starts to foam when a propellant is added, usually under high temperature and pressure. By contrast, organic waste is usually heat sensitive and cannot be processed at such high temperatures. It's very difficult to achieve the desired elasticity of foam using biomass, Dr. Sediva explained. Zuzana's solution involves the use of a novel propellant that is added during the manufacturing process, which enables the biomass to foam at lower temperatures. The biopropellant is completely green, unlike the synthetic additives used in the production of traditional foamed plastics. It is based on a mixture of gas and water, which Dr. Sediva developed as part of her dissertation at ETH Zurich. In 2019, she filed a patent for it in partnership with ETH. She is currently looking for industry partners for packaging as the entry point, as well as the shoe industry. I hope you enjoyed that clip from the Conservation Win Show. If you did, go ahead and subscribe to my YouTube channel so that you can stay up to date on all of my future content. To watch the full episode that this clip came from, click the link in this video's description.